What you see on this slide are examples of different shapes for distributions. On the upper left, you see an example of the bell-shaped curve. The bell curve is symmetrical in that the two halves of the bell curve are mirror images of each other. The score values, x values, are organized on the horizontal axis, with the lower or negative score values always being on the left and the higher or positive score values always being on the right. So numbers increase in value from left to right. In a normally shaped distribution, the scores array themselves in a predictable, consistent pattern, with 68% of scores typically falling plus or minus 1 standard deviation from the mean, 95% of scores typically falling plus or minus 2 standard deviations from the mean, and 99% of scores falling plus or minus 3 standard deviations from the mean. Click on the link next to the link for this video entitled The Bell Curve. We will be adding to our knowledge of how we map out the interior of the bell curve in the next few chapters. Variations to the normally shaped bell curve are called skewness and kurtosis. Skewness and variability are usually related. The more the skewness, the greater the variability. But more variability does not necessarily mean more skewness. Skewness has direction as well as magnitude. Skewed to the right, or positively skewed, means that the curve leans left and trails off to the right, towards the positive end of the scale, as is shown on the slide. Skewed to the left means that the curve leans to the right and the tail trails off towards the left, towards the negative end of the scale. Maybe it will help you to remember if you use the phrase, "the tail tells the tale." That is, when the tail extends towards the positive or higher end of the scale, we call that positive skewness. Conversely, when the tail extends towards the lower or negative end of the scale, we call that negative skewness. Kurtosis is how peaked or flattened the shape of the distribution appears.